What's up everyone, today we're going to discuss how to check whether or not a number is a perfect square. I'm going to show you two possible solutions, one involving loops and the other takes advantage of the nature of perfect squares. Let's begin by including the header files that we need. For our first solution, we only need the standard input and output header file. Now, let's work on our main function. We're going to declare this integer variable where we're going to put the user input. We're then going to tell the user to enter a number. Then, we are going to get the input and assign it in our integer variable. After that, we are going to pass the number into our perfect square function. Before we begin with the algorithm, let's first talk about our game plan. Let's consider checking whether or not the number 25 is a perfect square. Our game plan would be to get all perfect squares before 25 by iterating and multiplying the iteration by itself. If one of these squares is equal to the number, it means that the number is a perfect square. In this case, we see that there is a square that is equal to 25, therefore 25 is a perfect square. Now let's consider the number 24. So far there are no squares that are equal to it, and then we reach 25. We don't want it to continue iterating until infinity, so we will stop when the square will become higher than 24, and then we will output that the number is not a perfect square, because there are no squares equal to it. Now let's write our function. We simply want to display whether or not the number is a perfect square, so we don't need to return anything. We will accept an integer as parameter and name it a. We will create a for loop to create all possible squares. We will start at 0 because 0 is a perfect square. If I times I or our square becomes higher than the number, we should stop to not increment infinitely. So our square should be less than or equal to our number, and then we'll iterate our I. If one of our squares is equal to the number, that means that our number is a perfect square. We will then tell the user that the number is a perfect square and then stop the function by putting return keyword. The reason we stop is because we do not have to continue checking. However, if none of the squares that are less than or equal to the number is equal to the number, that means that the number is not a perfect square. We then have to tell the user that the number is not a perfect square. Let's try running our code. Let's check if the number 49 is a square. Hooray! Now let's try checking if the number 50 is a square. Perfect. Now let's try checking all the test cases. Good. Now this is the solution that involves loops by checking all possible squares less than or equal to the number. Our next solution also checks whether or not the number is a perfect square, but without using for loops. However, we will need to include math.h functions. We are then going to create an integer variable and then put the square root of the number there. We are going to use the power function, but we can also use the sqrt function, but the power function is more versatile. To get the square root, we have to raise the number to the power of 1/2 or 0.5. Before we begin, let's understand the logic behind this solution. Take note of the variable we used for our assignment earlier because it will be important later. First, we know that the square root of 25 is 5. If we use the calculator, we know that the square root of 24 is this number. However, remember that the variable we are going to store this value is an integer, meaning that the value stored will be rounded down, so instead of 4.89, it will simply become 4. Here is the important part. In the case of 25, if we multiply the square root by itself, it will become 25. But in the case of 24, multiplying the square root by itself will actually become 16 instead of 24. And we are going to take advantage of this phenomenon. Let's have a condition that if result times result is equal to the number, it means that the number is a perfect square. Then we are going to tell the user that the number is a perfect square. If not, then we will simply tell the user that it is not a perfect square. Let's check the test cases to see if our theory is correct. As you can see, we failed because we did not use for loops, but we actually checked all the test cases. Hooray! Thank you guys for watching, and I hope you learned something new. Please like and subscribe as well as comment future topics that you want me to discuss.